So it should be. Yeah, so it's live now. Just check on your side if you can see it in the website too, like in YouTube. But yeah, it's showing on my side, like it's live. If you go to live, it shows there.
Okay, that's great, man.
Yeah, so then seeing we are good, then me just add you to host so you can go to. So do the recording as well, so you can start like the local recording.
Yeah, I'll start recording when people start joining because otherwise it will be too large and difficult to crop. Okay?
Yes, and your host. Okay, so we are live on YouTube. Yeah, seeing all is
I
good.
will I will email the people that subscribed with the link for the stream, and I will also email the authors with the link for the Zoom call. Okay?
Right. Just starting from now will be live, and then as soon as the Zoom meeting finish, yeah, it will be uh, the live also should stop. But yeah, just remember that now everything that is happening on Zoom is live on YouTube. You know, just to be mindful of that. Okay.
Yeah, sure. Okay, that's great.
Yeah. Yeah. So yeah, take care. Will talk. Yeah, let me know anything. You know, like in WhatsApp, whatever you need. I will be available. But yeah, we'll kind of we'll leave this open on the computer, but just take care of like the Zoom and the recording on your side.
Okay, that's great.
Okay. Yeah. Take care. Take care. Will. Bye.
Bye bye.
Bye. Bye.
Hello, everyone. Good afternoon. I see that we already have some participants here. Hello, José Luis. Hello, Manuel. Hello, Richard. How are you? Hello.
Hello, good
Hello,
afternoon.
everyone.
All fine.
Hello, everyone. We are just waiting for one other member from the evaluation committee to join. So we should be starting any minute now. Hello, everyone again. I think that we are all here. Juan Luis was the last member. He's now joining us. We have two members of the Undergraduate Consortium that sent an email saying that they were not going to be able to participate. But I would say that that's okay. So we have the majority here already, and I would like to give all of you a warm welcome from the LatinX in Computer Vision Organization. Let us start. Starting here and giving just a brief introduction to the program. Okay. So hello again, welcome once more to the Undergraduate Consortium online seminar. The idea behind this seminar is so that all of you can have the opportunity to present your work and also gather feedback from specialists in the field. This track is hosted by the LatinX in Computer Vision workshop that will happen at CVPR 2024. But of course, because of some of the limitations that we have to travel to the United States and actually attending there in person, we decided to also have a version of the seminar happening online so that everyone can also attend and participate. So this is also a more inclusive option for researchers in Latin America and also worldwide. This is again a space for undergrads to present and receive feedback from established researchers about the current research and next steps. And also in this online seminar, the students that were accepted in a peer review process will be able to present their work, discuss their ideas. So this is a space that we have separated for you to have this access to these members. The evaluation committee here, for some reason, Dr. Matias Montenegro here picture is not showing, but the evaluation committee is composed of three members. We have Dr. Matias Montenegro Toro. He's an assistant professor at University of Groningen in the Netherlands. Matias, if you want to say a few words about yourself, just say hi to everyone. You have the word now.
Sure, I can just say hi. Nice to meet you all, and I hope to have a great session today.
That's great. Thanks, Matias. The other member of the evaluation committee is Dr. Nils Muhakarelena. He is an assistant professor at the Weber State University in the United States of America. Hello, Nils.
Hi, Will. Thanks for the introduction. Well, the only thing that I want to say is like good luck to all the participants. And also, if you are here, that means that you are very well prepared. So good luck, take some time, take some break, and good luck with the presentations.
That's great, Nils. Thank you. And we also have here Dr. Juan Luis Gonzalez Bello. He's a postdoctoral researcher at KAIST, the Korea Advanced Institute of Science and Technology in South Korea. Hello, Juan.
Hello, everyone, and thank you for being here. We are already proud of you. You are taking a big step in your career. Like, we wish we had that opportunity in our time, but I think you are in a very good position now. So good luck.
That's great. Thanks, everyone. So just a bit introduction on this program. So first we have this block here that we are just introducing ourselves, giving some more details about the seminar. We will then move to the presentation blocks. This will be 6 blocks of 20 minutes each. I will give more details on how we can use these 20 minutes in the following slides. We will then move towards a deliberation. The evaluation committee will have a discussion on the best presentation that was given here today. And then we can have the closing remarks in where we will announce this best presentation and also again send it here to the community. This 20 minutes block, they will be broken down to 2 smaller blocks. So you have until 10 minutes to present your poster. So you can share your screen, open your poster in your screen, give your presentation. It's ideal that you can use your mouse or maybe some other tools that we have here also on Zoom to point to the posters and give your presentation. After these 10 minutes, we have another 10 minutes that are separated first for the discussion from the committee. And then if we have some time left, we can go to Q&A from the audience that is watching this live stream in YouTube. From the submissions that we have received and that were accepted for the second stage, we have scrambled this so that we have a random order of presentations. So in this case, the first presentation will be by Jose Barba from the Trujillo National University. The second presentation will be given by Isabela Ribeiro from Voxa Labs, Universidade Federal de Pernambuco. The third presentation will be given by Victor Nascimento from Institute of Mathematics and Statistics, University of São Paulo. We will then go to Richard Zingri from Machala Technical University. Then we go to Manuel Malha from Machala Technical University. And finally, Alejandro Aparcedo from University of Central Florida. The criteria for the decision of the best presentation here is the clarity of the presentation and also the poster, the impact that this has in social life for people that are in Latinx communities, and also the clarity of the next steps of the research and the future works that we present after the undergraduate works, for example. So that was it from my part. Do we have any questions from the participants? No? So I think that Jose Barba, if you are ready, you can already go start sharing your screen, present your poster.
Hi, I'm ready.
Okay, so we can go
Okay.
ahead. Just one more thing, I will start recording this session so that you can also have the videos after, okay? So just 1 second, please, for me to start recording. That's great. Okay, so Jose, please share your poster with us. Go ahead, you have 10 minutes to present your work.
Sorry, one moment. My freeze PC, freezing.
Hello, Jose?
Hi, I am Jose Luis. I am computer science student at the National University of Trujillo. Now I'm going to present my presentation. My presentation is cementation of the oil spill in the Peruvian Sea for rapid location.
Excuse me, Jose, but we cannot see your poster. We cannot see your poster here on the screen. So maybe if you stop sharing and try sharing again, then we might be able to see it.
In Peru or other country, oil has a high importance in society, but palette the environment.
Sorry, Jose, we still cannot see your poster. It's like a white screen. I don't know if the PowerPoint or you need to reshare your screen.
Yeah.
Okay. Sorry.
Yeah. Don't worry, Jose. If you need some time for setting up everything, we can go to the second participant and then we can return to you after.
I can.
Okay,
We can
now we
we
can see
now.
it.
We can see now.
Yes, now we can
Got
see.
it. Okay, so
Okay.
I'm
Sir.
resetting your clock. You can start again. Go ahead.
Okay. In Peru or other countries, oil has a high importance in society, but pollute the environment. When an oil spill occurs in the sea or rivers, we must detect or cleaning immediately because an accident maybe occurs has happened in Peru, destroying an important ecosystem. For example, in Peru, lost 7 million square meters of ocean. In Peru, authorities don't have a rapid oil spill detection system. Other problem is the this causes a problem in the economy on fishing sector. I think that predict the environment damage help to make better decision. To quality cementation, the initial help us in predict the effects in the trajectory, need to rapid cleanup. How can I predict this dispersion? For example, can you see in the image this oil spill area? I use convolutional neural network to segment the concentration of the oil spill, environment damage, and predict its dispersion. I get information about physical information. For example, the oil color, and they are oil color, silver shame, pine bone, true color. To get image, I use a real-time system, but real-time system the image has noise. But to reduce this noise, I use bilateral filter. Bilateral filter smooth the image and reduce the noise. Other operation is use software operator. Software operator, with software operator, I get the edge of the oil spill area. And next, I use this image to combine with linear combination to get a clean image with the edge of the oil spill area. Next, I use YOLO VHSEC to get the segment the thickness of the oil spill. I use YOLO VHSEC because support cementation, and YOLO VHSEC is lightweight. Other property of YOLO VH architecture is the heap is connect with backbone. This connection heap high feature important of different states of the network. Other property of YOLO VHSEC is C2F module. C2F module provide high information to improve the detection of accuracy. Next, I get the segment of the image with your class, with its class. For example, this image is true color. I get the image from dataset, RoboFlow dataset. This provide 921 images or 600 per 600 resolution image. Each image has label, silver sheen, rainbow, and true color. Other property of image is the polygon edges, polygon point. Other property is the backbone. Next, I use this image to predict the oil spill dispersion with automatons, with cellular automatons. Cellular automatons is a dynamic system to predict the spread of the oil spill area. This change in function of neighborhood and the gradient of the ocean current. Gradient of the ocean current is the direction of the ocean current. This damage change in the time. For example, in the image, this is the time 0, this is the time k, this is the time k plus. I use to train my model mean average precision metric. Other problem is the imbalance data. I use if one score measure to maximize precision and recall. Other metrics is the G-mean score to maximize the sensitivity of the image. To measure the bounding box, I use CU log function. I use CFO log function because CFO CAO log function has 3 important factors: overlap area, the center point, and discriminate aspect ratios. Next, I think that this information of the forest caps, the speed dispersion, environmental agencies can take prompt action with legal proceeding. Peruvian authorities don't have a rapid oil spill detection system. This system is low cost and help in get better decision. Thank you.
Thank you, Jose Barba. So moving forward to the questions from the evaluation committee. Hello, Nils, you want to start giving you some comments and questions to the presenter?
Okay. Thank you, Will. Thank you very much, Jose, for the nice presentation. Also the setup, the layout of the slides. I have couple of questions. First is about the data set. I don't know if you can talk a little bit about the data set that you have, or you plan to collect some data. How are you going to do that step?
My first step is the RoboFlow data sets in the web. This provides 921 image, but I can get other data set in the web, or satellite image, or image of authorities, Peruvian institutions. For example, in Peru, Peru has satellite image of this area. The last week was oil spill accident for Rexol. This image, I can get more information in my training model. Other solution is data augmentation, because some days the ocean is sunny day or cloudy day or dark day. I use computer vision operation como as light adjustment or synthetic fold or rotation or scaling image.
When you're mentioning the clouds or something like that, do you mean to synthetically create some clouds or some way that you can create much more data, or what do you mean?
In the light, I can see this operation. I use computer vision synthesis fog. Other is the ring adjustment, because is the Peruvian ocean is very cool, and there are fog in the real time system. This fog is a noise.
Great, thank you. Please, can you go back to your poster? You were mentioning something of the cellular automaton, no? And I think you have to have different images at different times, time 0, time k plus 1. How are you getting that information if you are only having images?
Can you repeat, please?
Yeah, so in the step number 4, in the cellular automaton, I believe you have different, I don't know, time 0, time k plus 1, different locations or different representations of the oil spill, yes? If I understand correctly, on your data set, you only have the images, the images, you don't have like a video. So how are you going to use or create that data to your problem?
Okay. I get video information to represent the simulate. Others in my sample is the dynamic function with parameters, with physical parameter as a ocean current. And I think that I get more information about trajectory or forecasting dispersion. This model can be good.
Great, thank you, Jose.
Thank you.
Thank you, Niels. Matthias, you have the word.
Yeah, thank you for the presentation. So it's interesting. So the problem has, let's say, societal impact. One question I have is, have you considered that the model can make incorrect predictions? So what would you do in that case? Or how would you solve this problem? Or have you thought about this?
Incorrect prediction in dispersion oil spill?
Yes.
Oh, yes. I don't information about dispersion. I try simulate the prediction on spill area. I meet with other scientists in physics or marine physics to predict the dispersion. This is idea to predict oil spill dispersion. In first step, I use cellular automatons because the system is analog a matrix pixel of the image. Is easy in represent this pixel as a cellular automaton. For example, this a cellular automaton represents the pixel EJ. The cellular automaton represents and that's the thickness of the oil coloration.
Yeah, okay. So what I mean, or more like a general feedback, is that you should always consider that the model may make incorrect predictions depending on the training set and the data as input data. And for example, if you want to use a model like this in like a legal process, the first thing they will ask is how do you make sure that the model is right? So for example, even very large models like ChatGPT can give you what people call hallucinations, right? So that can also happen in this case. So maybe for the future, you should consider some kind of uncertain estimation or something to actually see, try to prevent, for example, incorrect predictions, like to give a confidence for the predictions. That would be useful, especially in legal proceedings. But that was all my comment.
Mhm. Thank you very much.
Thanks for the feedback, Matthias. So, Juan, you have the word now.
Yes. Thank you for your presentation, Jose. And as far as I understood, the system takes as input a single image, right? But have you thought about incorporating more information? For example, maybe the drone has some kind of altitude sensor, or you could also use, like, as you mentioned already, like the time of the day and the season as well. And like instead of feeding one frame, feeding multiple frames, just to better condition the model. Have you thought about that?
I can difference model to time. For example, in the night, a model to dark day. Other model to um, um, sunny day. In the altitude, I use the altitude in the drone because the drone different altitude is different representation in the image, correct? Um, other problem is the cloudy day. I use different operation to get more information and to improve the model generalization. But I have I have different training model because dark day is completely different with sunny day.
Okay. In that sense, I think my feedback would be that it's better to have a single model that has additional inputs that condition the network in a different way. So maybe your model not only takes as input the single image, but also takes as input the time of the day, the season, the altitude, and other variables. So you don't have to train one model for each independent scenario, because sometimes you will have like an intermediate or like an interpolation of those two conditions. And if you train a single model with additional inputs, then it will more naturally learn how to interpolate from very early in the morning to like late in the day. So, and I think the same will go to the altitude. It will be interesting to see how the performance changes as you capture at different altitudes. Maybe you can even improve your confidence by capturing the same oil spill at different altitudes, and then you take the average of the several predictions, and maybe that can also help in improving the performance.
Thank you very much.
Mm-hmm. Yeah, and that's it for me.
Thanks, Juan. So, Jose, that was a very nice presentation. Thank you. You have here a lot of comments in the chat congratulating you also for the problem that you're trying to solve. I just wanted to ask you a bit about your vision for the next steps of this project. Like, do you envision maybe this going into a master's program or a doctorate program to improve more details on this work? And if so, what do you think can be improved here?
I see a question in the chat. What is the focus or problem to solve? We need immediate detection and origin speed and to predict its dispersion to make a good decision to clean up and the damage, environment damage. I see others. What has been done? What has been done? I made an oil spill detection system to predict the spread environment damage to get more information to clean environmental damage. Others. What are the results? I offer a low-cost solution to problem that cause economic and environmental damage in Peru.
Yeah, I think that's great, Jose. We are already on the top of our time, so thank you again for your presentation. Very nice work. Really appreciate it. Thank you.
Thank you.
So moving forward now to the next presenter, we have Isabela Ribeiro from Voxa Labs, Federal University of Pernambuco, with the work entitled Evaluating Structural Distortion in Anonymized Faces. So Isabella, if you are ready, you can start sharing your poster, and we'll have 10 minutes to give your presentation.
Okay, I'm ready. I'm gonna share my screen. Can you see?
Yes, you can see the screen.
So, and can I start?
Yes, you can start. You have 10 minutes. Go ahead.
Hello, I'm Isabella. I'm from Universidade Federal de Pernambuco in Brazil, and I'm presenting my work, Evaluating Structural Distortion in Anonymized Faces, which was co-authored by Williams, Maria Luisa, and Veronica Taiti. So I'm going to start talking about computer vision applications that use facial recognition, because the number of these applications is growing more and more, and with that, it's also increasing the concerns on data privacy. So we have, for example, banking applications that use facial recognition for authentication. We have surveillance cameras that use facial recognition to conduct behavior analysis. And with all that, the users often don't know where their data is going, for what purpose it's being used. And sometimes they don't even know that the data is being collected at all. So in this context, the anonymization algorithms have emerged as a way to protect the user's privacy. And they do that by modifying information and removing information from the data that can identify someone. So in the context of computer vision, we have two different approaches. The first one uses naive algorithms that blur, pixelate, and mask the image. And we have more robust algorithms that use generative networks to not only cover the person's face, but also generate a new face for that image. So these approaches, they not only minimize the loss of information, but also maintain the semantics of the image. So with that in mind, our main goal in this project was to quantify how much the anonymization algorithms distort a face. And we also did a secondary analysis on the utility of the anonymized images in the context of computer vision tasks. So firstly, we started by selecting 3 different anonymization algorithms. The first one is DPrivacy2, which is the current state of the art in anonymization, and it uses a generative network. The second one is SGGAN, which also uses a generative network. And the third one is pixelation, which is a naive approach that only pixelates the image. And it's very used in comparative studies as a baseline for the comparison. And after that, we selected 3 different facial data sets. We have the first one is SkyEarth, which is a data set that was built on images of North American movies and TV shows. We have some samples of it here. And these images are very used in the wild analysis and context. The second data set is FAIR 2013, which contains images that were obtained in online search engines, and all of the images are black and white, as we can see here. And the third data set, it was built in a controlled environment, which is KDEF, which we have some samples here, and it was built in laboratories. So we have these different approaches to each data set. And our method consisted in taking these 3 data sets and anonymizing them in the 3 algorithms that we selected. So in the end, we had 9 different anonymized data sets. And for all these images, we used MediaPipe to generate facial landmarks, which are these meshes we can see here in the images. And each of these meshes have 478 points. So we took these points and we calculated the endpoint error metric, which consists in the Euclidean distance between each of the points from the original image to its anonymized version. So the average of these distances is the structural distortion that we're calculating and analyzing. So before talking about the main results about the distortions itself, we did a previous analysis with MediaPipe's face recognition detection rate, because when MediaPipe doesn't recognize a face in an image, it doesn't generate a facial landmark to it. So we can see in this graphic that Deep Privacy 2 is a technique that had the highest detection rate for all 3 data sets, which we can see in these dark bars. And this means that Deep Privacy 2 might be generating images that are more realistic, more close to what a human face looks like. And on the other hand, SGGun had a pretty bad result with FAIR 2013. MediaPipe only recognized 4% of the data set. And this shows a vulnerability in SGGun in anonymizing images with lower resolution, which is a characteristic of this data set. The images are very small and low resolution. So after that, we have the final results regarding the average structural distortion, and we can see that Deep Privacy 2 had the highest distortion for all 3 data sets also. The mean average is 15.3 pixels. And in the beginning, this might seem that it's a bad thing, because you can conclude that because it's distorting too much, it might be destroying the structure of the image. But when we combine these results with the previous analysis using MediaPipe, we can conclude that actually Deep Privacy 2 is distorting the face enough for it to be anonymized, but at the same time, it's still preserving a facial structure for it to be recognized in facial recognition algorithms. So in conclusion, our research showed that Deep Privacy 2 between these 3 techniques is the one that has the best balance between preserving the user's privacy and maintaining the utility of the anonymized images for computer vision tasks. So for future work, we intend to use these calculated distortions to analyze fairness in anonymization algorithms and to see if there are any misrepresented groups in these algorithms. So we could potentially improve an architecture of a generative network using this data. So that's it. Thank you very much.
Thank you, Isabella, for your presentation. We will now move to the considerations from the evaluation committee. So, Matthias, we can start with you at this time. You have the word.
Thank you. So this was a very nice presentation. So I think the problem is clear. But what I find a bit not problematic, but you mentioned that there is a relationship, let's say, between how much the face is, let's say, distorted. And I mean, that's the point that you want to do to anonymize the face, right? So that depends on how you anonymize. So can you discuss a little bit? Because one will expect that to anonymize the face, you have to destroy part of the information, right? And then, but that means that the ideal anonymization would keep like the face intact, but somehow anonymize it, right? So I think one can expect that you have to destroy some information, but not distort it. So how is this? It's kind of a dilemma or a trade-off like that?
Yeah, it's a very subtle thing. Like in the beginning, we were thinking like, oh, let's analyze the quality of the anonymization, but the quality aspect was very ambiguous. So we tried to find this balance between like, you want to change the face of the person so that it is different from the original face. So in this way, you can keep the user's privacy preserved, but at the same time, you don't want it to look like it's not a face. So there's this balance that we're trying to reach. So for example, in this example here, we can see that there is an aspect of a face in this image, but there is still some destruction of the face in some way. So that is considered like a bad anonymization. So there is this balance between analyzing the qualitative results and the quantitative results of a distortion.
Yeah, okay. So I think your work is basically trying to define how do we evaluate the quality of anonymization, and I think that's very important.
Yeah, that's one thing that we saw during the research, that each of the anonymization algorithms uses a different metric. So sometimes it's difficult to find a general metric that we can use in OWORDS, for example.
Yeah. And can you also comment a little bit on the face recognition plot? So here the idea is that the face can still be detected as a face, but not recognized as a specific person. So that is what the is showing?
Yeah, because when we were doing the experiments, we saw that MediaPipe wasn't generating the landmarks to all the images. So we were trying to look after the source of these failures, and we saw that most of them were coming from the anonymized images. So we have actually a table in the article, in the paper, saying that, showing this data, that at least 77% of the failures was coming from the anonymized images. So we concluded that MediaPipe was detecting the original image as a face, but when it comes to the anonymized version, it wasn't detecting a face anymore. So we saw that there was this problem going on. So that's why we did these extra analysis on top of it.
Yeah, very nice. So one, like my kind of final comment is that maybe you can also take a look at the model, let's say confidence or uncertainty, because if the face is anonymized, then the model basically should say, okay, I don't know who this person is. And maybe you can also use an initial metric to compare, for example, the entropy of the classification probabilities to see that, okay, now you are tricking the model and it doesn't know what person it is. So it's something also you can use for evaluation for different models. But
yeah,
overall,
that's very interesting.
Yeah, thank you for the presentation.
Thank you.
Thanks, Matthias, for your remarks. We'll move to Juan. Juan, you have the word.
Yes, thank you for your presentation. It's very interesting. So as far as I understood, this is a study to see which algorithm is the best for anonymization, right? And which metrics you can use to better decide which one is the best.
Yeah.
But one thing I wanted to ask you is, what about the adversarial attacks that could happen on the media pipe model, for example. We know that these adversarial attacks, they can be even 1 pixel difference, and that make the model completely useless, right? So did you explore that venue when you did this analysis?
Can you repeat, please? I don't think I understood fully.
Yes, I mean the adversarial attacks that can happen on deep learning models. Like, for example, there are some adversarial attacks that you change 1 pixel, and then instead of detecting some image as a truck, it detects as flamingo, for example. So could that happen here, that you get some kind of adversarial attacks that make your metrics like useless because of this adversarial attack? Did you consider that during the analysis?
Yeah, I didn't consider that. For what I understood, it's like if I, for example, occlude some part of the image, then it might give a different classification like this.
Okay.
Yeah, I didn't consider that, but it's actually something interesting. One thing that we noticed was that the images anonymized by KDEF specifically, they have very, it's a data set that has very like structured angles of the faces. So we saw that the faces who were anonymized that were completely on like looking to the side, they were harder to be identified in media pipes. So we saw that there was a correlation between the poses and media pipe detection, but some other aspects beyond that we didn't really see, but it's something to look forward to.
Okay, thank you. And my other question is, now that you have done this study and you know like which properties to look at, are you thinking about on making your own face and animation model for your future work?
Yeah, when we think about analyzing fairness on top of these algorithms, we think about improving the algorithm towards fairness. So that's something that I'm looking forward to, and to see if there are any misrepresented groups. So for example, in this data set, they are all very North American focused. So we don't really know if other ethnic groups, for example, could have different results. So it's something that we want to investigate.
Okay. In that case, it will be also interesting to see that kind of analysis, the same analysis you did here, but on the other groups, right? Even if they were not belonging to the training set.
Yeah, exactly.
Okay. Yeah, thank you.
Thank you.
Thanks, Juan, for your remarks. We can now move to Niels. Niels, you have the word.
Thank you, Will, for the time. Thank you also, Isabella, for the presentation. The first question is like, I understand that the faces can be in different angles. Yes, can have like some rotations or can be some movements of the head or something like that. When you are doing your study, do you consider that cases or you disregard that part?
We considered in the beginning, but it was something that we were analyzing during the experiment. So with the results, we could see like, do a comparison, like what was MediaPipe detecting best and worst. So it was something very dynamic in this sense. It was not really like we were expecting to find X and Y, but we were analyzing during the experiment.
Yeah, because other thing, if we like try to do much more simple, probably you can see if you have a front side of the face, yes, left side, right side. And I don't know how robust are these anonymization methods to that case, yes. So I would suggest to, if possible, if the dataset have that information, to have that analysis when you are doing that. And I think other thing, probably, I don't know, if you have information about the age or about the gender or other informations, you can also try to do some ablation studies. Yes, probably you can find some models that work best in some scenarios and others that don't work best in other scenarios. And also in the sense that probably you can develop like a new approach or new idea. What are the key parts of this approach? Probably they have already in the methods that you consider, but what would be some ways that you try to define like a new loss, or what will be the losses that you have to ensure to provide this anonymization method?
Um, Let me see. Losses, I don't really know, but I know
Or
that,
maybe, for example, what will be the goals? What will be the goals of this new approach that you, if you want to provide anonymization, what do you like to ensure in the new images?
yeah, I believe the main thing is to reach the anonymization itself. So the identity of the person is changed in the anonymization. That's the main part. And I believe that the um, the utility part of the anonymized images, like, are the anonymized images able to be identified in computer vision tasks and other algorithms of facial recognition, are a secondary part. But I believe the priority must be like doing hiding the identity of the person.
Yeah, so maybe, I don't know, my understanding is that probably you try to find some key differentiators of that per people. I don't know, the eye or some forms that probably you want to keep that information in some way. But at the same time, you want to reduce some information. Yes, I don't know, the color of the face or the form of the nose or something, so that at least you know that it's not that person. Yeah, so probably in that sense, you have to develop two losses. Yes, one loss for the first part and another for the second part. And I'm not sure if already the methods that you are evaluating do that part already. Yeah. And I think that was much more of my questions. Also, one more suggestion is like, when you're having your poster, something that I'd like to have is maybe the key idea of your approach or the method that you have, and also try to add some organizations. Yes, like what's your approach, what is your evaluations, if you have quantitative experiments, qualitative experiments, and also the conclusion that you develop at the last part. Yeah. Okay.
Yeah.
Thank you, Isabella.
Thank you very much.
That's great. We are already on the top of the hour. It was a very helpful discussion. Isabella, thank you for the nice presentation. We will now go to the next poster that is entitled Efficient Video-Based ALPR System Using YOLO and Visual Rhythm by Vitor Nascimento at Institute of Mathematics and Statistics, University of São Paulo. Victor has actually emailed me and said that he will not be able to join us because he's recovering from a surgery. But he recorded the video, and what I'm going to do now is we're going to play the video, see his presentation, and in case that we have any questions, you can just send an email to him. And of course, I think that he will be very, very capable to respond any of our questions. Okay. So I'm just going to present here, and we can go ahead. Okay. So please let me know when you can see the.
We could see it, and then it went blank.
You can. Yeah, my Zoom crashed. Let's
Okay.
try again. Let's see. What about now? Okay, I'm going to play the video now then.
Hello everyone, my name is Vitor, and today I'm presenting the work Efficient Video-Based ALPR System using YOLO and Visual Rhythm. So first, ALPR stands for Automatic License Plate Recognition. It involves the task of capturing vehicles' license plate information from an image. And these kind of systems have gained in popularity thanks to the widespread accessibility of surveillance cameras, and advances in deep learning. However, this task is not simple because capturing clear images of moving vehicles' license plates is hard due to the many formats of license plates and inconsistent outdoor lighting conditions in video captures. Thus, there is still a demand for research on ALPR systems. In real-world scenarios, video-based ALPR systems rely on multiple frames rather than a single image. So, in this work, we present a more efficient approach for video-based ALPR by creating a time-spatial representation of the video into a single image. So in this way, we can selectively extract and process a single frame per vehicle, facilitating license plate character recognition using UCR models. But first, we need some background knowledge to understand how the methodology works. Visual rhythm, or VR, gathers spatial and temporal information, condensing the video content into a single image, facilitating the identification of frames containing crucial information, thereby reducing the computational complexity tied to the frame-by-frame processing. The VR image is created by capturing pixels along a predefined line and stacking them along the time axis. So, for instance, see the image on the bottom left corner. It is a representation of a video containing 150 frames of height m and width n. The VR method is applied to all frames of the video, capturing exclusively the pixels along the line represented in green. And this collection of pixels are then stacked along the time axis to form an image of size 150 by n, creating a time-spatial representation that summarizes the entire video. The usefulness of this representation is that whenever an object crosses the line, a mark is observed in the VR image at the row corresponding to its frame index, and each object is represented by a single mark. In this way, we can easily know the moment where the object crosses the line, so we can extract this frame and process this single image. Additionally, the VR method can be applied to various applications, as long as the analyzed objects move unidirectionally in a top-view video. YOLO is a real-time object detection model that has gained significant attention in computer vision. Regarded as the current state of the art, this model can efficiently predict bounding box and class probabilities for multiple objects in an image. OCR stands for Optical Character Recognition, and it is used to decode license plates content. In this work, we employ EasyOCR, a specific implementation that adopts a CRNN architecture and simplifies the process of integrating OCR capabilities into the application. Now, for the methodology, our ALPR system follows these steps. First, we define the line position, and in step A, we create the VR image that will contain a mark corresponding to each vehicle that crosses the line. In step B, we employ YOLO to detect each mark within the VR image. Detecting these marks could be also achieved through background subtraction techniques. However, these methods could fail in handling varying weather conditions and other sources of noise. Next, in step C, for each detected mark, we extract the corresponding frame from the video. To achieve this, considering each mark as a representation of a vehicle, we can infer that the y-coordinates of the mark's bottom corresponds to the temporal index of the frame when the vehicle entirely crosses the line. After obtaining the frame, in step D, we employ YOLO again to detect vehicles in this image, followed by the step E, where we identify and crop the specific vehicle represented by the mark, by comparing its bounding box X coordinates with the mark coordinates in the VR image. Continuing, in step F, YOLO is utilized to identify the license plate coordinates, followed by step G, where we refine the image by cropping it. Finally, in step H, an OCR algorithm is applied to extract the characters from the license plate. Before testing our approach, we fine-tuned YOLO V8 Small for vehicle, license plate, and mark detection using a task-specific dataset. To conduct the experiments for this work, we'll use the vehicle rare dataset, where it contains a set of videos that met the constraints required by the VR method, while also featuring vehicle license plates with high resolution in the Brazilian format. To evaluate our approach, we'll use character error rate, a metric that divides the number of incorrect characters to the total count, so the lowest the better. The early experiments were conducted exclusively on video 5 from camera 2 and achieved around 15% character error rate. It's important to note that if one of the earlier steps fails and it becomes impossible to extract the license plate content, we consider that the approach has misread every character on the metric calculation. These results shows promising performance, given that YOLO was fine-tuned on a separate dataset under different circumstances, and we are using a generic OCR model. Based on these findings, we conclude that the methodology is feasible, but there's ample room for improvement. Our next goal is to fully explore this problem, to improve computational efficiency and recognition efficacy. And some ideas we have in mind are training YOLO in the vehicle rare dataset for both marks and vehicle detection and exploring different OCR models. We would like to thank Ministério da Ciência, Tecnologia e Inovações and FAPESP for supporting this research. Thank you for your attention.
So that was the work by Vitor Ribeiro. Again, he's not here with us today because he's recovering from a surgery. But in this case, if you have any questions, you can just send directly to them via email, or you can also send them to us, the organization of the event, and you can forward them to Vitor. Okay? So moving forward to our next presenter, we have Richard Zingri from the Machala Technical University with the work entitled Improvement in Chagas Disease Detection in Latin America, Generation of Synthetic Images from Blood Samples using SynGAN and Evaluation in Random Forest Models. Richard, are you here with us today? Hello, Richard.
Yeah, I am ready.
Okay, so you can start sharing your screen and you have 10 minutes to present your work. The time will start when you start speaking. Richard, you are on mute.
Excuse me.
Yeah, you can start again.
Yeah, repeat. Hello, my name is Richard Sukui from the Technical University of Machala in Ecuador. Today I will present my research on improving the detection of Chagas disease in Latin America by generating synthetic images of blood samples using SynGAN and evaluating them in random forest model. Chagas disease is an endemic tropical disease in Latin America caused by the parasite Trypanosoma cruzi. According to the World Health Organization, around 8 million people are infected each year. The prevalence of the disease is particularly high in countries like Brazil, Paraguay, Bolivia, Argentina, as shown in Figure 1A. Due to migration and tourism, Chagas cats have spread to the other regions of the world, for example, Canada or USA. Figures 1B and 1C illustrate the main modes of the transmissions. The vector, an insect known as the triatomine, can leave its feces on the food that humans consume, resulting in infection. Additionally, the bite of the vector is another transmission route, as the insect deposits its feces near to the wound, and by scratching, the person can rub the Trypanosoma cruzi parasite into the skin, allowing it to enter to the bloodstream. Figure 1D shows the body of Trypanosoma cruzi with its three main characteristics. the kinetoplast, the flagellum, and the nucleus. The most commonly used methods to detect Chagas disease are the three: ELISA, HI, and IFE. However, these methods can take from 2 to 10 days and have high cost, which has limitation in research for areas and which are lack of qualified specialists. Therefore, the objective of this research is to develop a detection model for Trypanosoma cruzi by creating synthetic images of infected blood samples using SINGAN and evaluating them with a random forest model with the aiming of improving the diagnosis of Chagas disease. Additionally, the use of privacy regarding medical data is another limitation for obtaining this type of data play with computer vision. Using generate adversarial networks, GANs, is ideal for creating artificial images in the context of medical data privacy because they allow generate synthetic data that preserves essential characteristics without revealing personally identifiable information of the patents. The reason for applying SINGAN in this proposal is because unlike other generative adversarial networks that require a large number of images, like the SEGAN, CycleGAN, SteelGAN, among others GANs. But SINGAN stands out as it can learn various details from a single image, whereas others can learn details from different images. In other words, my training dataset is limited, and SINGAN, by using a single image to generate synthetic images, is a proprietary generative model for this research. Additionally, the reason for applying random forests to evaluate the synthetic images is that in 2022, a study was published from which I took the dataset of blood samples images infected with Trypanosoma cruzi viruses, made publicly available on the Zenodo platform. This study also applied machine learning techniques for detection of this parasite, but the random forest technique stood out with results between best result. These results were 85% to 19%. Well, the method. To develop model, the following steps are proposed. Data collection. We obtained 570 images for training of blood samples infected with Trypanosoma cruzi, but also 105 images for testing. As complementary tools, there are two CSV files containing the labels and details for each image, such as the image name, the localization of parasite in the images, among other details, the label of the kinetoplasto, nucleo, flagellum, and the other important data. The SINGAN architect includes two main components, the generator and the discriminator. The generator receives random noise input and converts into synthetic images that mimic the texture and the details of the sample images. The discriminator evaluates the generated images, differentiating them from real images and providing feedback to the to improve the quality of the synthetic images. This iterative process across multiple scales allows the single model to generate high fidelity synthetic images. 2. Synthetic image generation. After generating images, the quality must be evaluated using 3 specific metrics for generate image models. Table 1 shows what the test metrics are. We evaluate the quality and diversity of generated images using the MCSIM, cosine distance, and CFIT metrics. the societal one. Random forest model training. We integrated the synthetic images into the training dataset and training the random forest model with the expanded dataset. After model evaluation. In this final step, we evaluate the performance of the random forest model using K-metrics found in table 2. Here we evaluate sensitivity, specificity, precision, F1 score, and outROC. We compared the performance with the argument dataset containing synthetic images and without the argument dataset. This proposed research approach has the potential to increase data on blood sample images infected with Trypanosoma cruzi, advance disease detection, and have a significant public health impact by providing an accessible and efficient diagnostic tool for reserve limited regions. Thank you for your attention.
Thanks, Richard. So now we can move on to the considerations from the committee. Juan, we can start with you this time. You can go ahead.
Thank you for your presentation. It's a very interesting topic. And my understanding is that you want to use SynGAN to augment your dataset so you can better train your, in this case, your random forest model, right? Okay, I guess that's a yes. But I would like to see, I think you have the results here, but the figure is so small. I would like to see what was the improvement from using the augmented synthetic dataset instead of only using like the small provided dataset. Can you show us that result? I think you are muted.
Please give me that.
Yes, the question is if you can show us the results,
Yes,
the improvements from using the synthetic data.
Thank you. Since it was undergraduate consortium research proposal, I have not yet started the development phase. Currently, I am working on my undergraduate thesis and have adapted this proposal to my thesis, exploring not only SynGAN, but also other generative adversarial models to generate synthetic images.
Okay, that's good. Don't worry. It's good that you are working on this. So, okay, you don't have the results yet. That's fine. But I also wanted to ask, like in these images that you show here, it seems the task to be too simple because the blood cells are red and the parasite is like purple. Is it like a real sample, or in the real images you have like other cells that have different colors or other organisms that make the problem more complex? Otherwise, if I just filter by red and purple, I can get exactly how many cells there are and how many parasites there are, right?
Yes, Trypanosoma, the Trypanosoma cruzi parasite often appears as purple or violet structure and the tiny flood samples, making it visually distinctive. However, the task is not as simple as the mycem. The parasite can vary in appearances due to the difference in staining of the techniques, sample qualification and presence of the other blood components. By using SynGAN to generate diverse synthetic images, we're trying to train the random forest model to recognize this variation more accurately and robustly, improving the model's performance in the world journeys in the life.
Okay, I see. Thank you. That's important like to understand for us to see what is the impact of the future work. And one other question I wanted to ask is that like in these images, these parasites, do they move around or they are just static?
Can you repeat, please?
Yes, that the how do you call this parasite? It has motion when you visualize it on the microscope, or it is just completely static. Because if they have some dynamic properties, that could also be used into your model, right? Because I guess the dynamic properties of the parasite will be different to the blood cells, so that could also be used to improve and better condition your model.
Trypanosoma cruzi parasites those no, it's static, the matches. No,
Okay.
yeah.
Okay. Yes. Thank you for your presentation then.
Thank you, Juan. Niels, we can go ahead with you.
Thank you, Will. Richard, thank you for the nice presentation and also the nice poster. I have some couple of questions. For the data collection, I assume that you have at least two classes, yes? If there's no disease and if there is the trypanosoma disease, yes? In your case, do you want to generate new synthetic images for all the data set or for some specific class?
Yes. The reason for this is to augment the data set with more examples of better learn the variations of charities of the parasite. And this target augmentation will change the model. Can change the model solitary corticelli and similarly detect the presence of the parasite in the images.
But for example, how many classes do you have? How many categories do you have in your data set? Or you don't
Yes,
have?
and in the data set, I have to do two categories. And so the trypanosoma cruzi parasite, three forms: epimastigote, tripomastigote, el otro, y epimastigote. So this research is focused on the form tripomastigote. This fast in the chronic phase. This size.
So if I understand you correctly, all images has the disease present in different levels of complexity. Is that correct?
Yes, this is correct, and the image is the best.
Okay, yeah, got it. Yeah, so in that case, your random forest model want to predict in which level of complexity is the disease. Is that correct?
I don't understand. I can't please.
So your random forest model, it wants to predict if it's level 1, level 2, or level 3 of the disease.
Oh, yeah.
So you don't have any healthy cells or healthy sample in your data set currently.
And the results and application and the random forest models actualmente the results I don't have results because it is preliminary research purpose.
No, it's okay. I only want to know if you have a healthy class, but for what I understand, basically you don't have any healthy class. You only have the different levels of the disease. Yeah. One thing that I am a little worried is that you have some metrics to measure structure, diversity, or fidelity, but also I don't know how much are the class imbalance. I don't know, you have more images of level 2 or level 3, and maybe you have less images on level 1, yeah? So in that case, I think it's better maybe, depending on the data set size or something, try to generate much more images of level 1, yes, or level 2 or level 3. So I think that would be something that you need to consider when you are evaluating. And also, other thing I believe, as future work, probably you want to develop this in a system, or like some people to detect this disease. Yes, in that case, maybe you have to have also healthy samples of these cells. Yes, so you at least are aware that the disease is not present there. But what are your thoughts? We cannot hear you, Richard.
This research finally in the application. So in the future, yes, this maybe this investigation will maybe evaluation a software application for detection of Chagas disease.
Okay, thank you.
Thank you, Niels. So now we can move on to Matthias. Matthias, you have the word.
Yes, thank you for the presentation. So maybe to make it a bit short, I have only one question. So why do you use GANs? Because like the best model currently to generate images is the diffusion model. So for example, stable diffusion and most models that generate images now are based on diffusion models. So why do you use a GAN and not a diffusion model?
Okay. Single is just because it can generate high quality synthetic images from single input images. This is particularly useful when the training dataset is limited, which is common in the context of medical images. Other GANs, models like the SEGAN, CycleGAN, SteelGAN, others, require large amounts of images to train effectively.
Okay, perfect. Yeah, thank you. That's all for me.
Thank you also, Matthias. Thanks, Richard, for your presentation. It was a very nice presentation. And now we can move on to the next work that will be presented by Manuel Malha from the Machala Technical University. And this work is entitled MangroveNet, Mapping and Monitoring Mangrove Ecosystems Based on U2Net Model Using Satellite Images. Manuel Malha, you can start sharing your screen, and when you're ready, you can start your presentation.
Okay, thank you. Good afternoon, so I will start. Hello, my name is Manuel Sumaya. I am an undergraduate student from Ecuador. I study at Universidad Técnica de Machala, and my research is titled MangroveNet Mapping and Monitoring Mangrove Ecosystems based on use coordinate model using satellite images. So before to start, I had to mention that this research topic was proposed in the second regional workshop, applications and research, and it was selected to be shared with other data science professionals. And now in this undergraduate track, I decided to go deeper with this research with a specific methodology and a specific architecture, model architecture. So what is the problem that the research aims to solve? In simple words, it is mangrove reforestation. The mangrove deforestation is a big problem nowadays. In the recent decades, years, many countries like Ecuador, specifically in my province, Loro, we have seen a decline in mangrove areas, and this is a solution to reforestation. But how an application of artificial intelligence can help to reforestate? Well, the answer is using maps on mangroves. Okay, I will explain where's maps on mangrove in a few moments. So in order to support mangrove management and protection, it's essential essential to improve monitoring capacities. Here I tried to an image from Sentinel-2 satellite. It is the area of my province, of my group. And the four main objectives of this research, they are: one, develop a fully convolutional network, a convolutional network model that is based on Use-CoordNet. To use and merge satellite data to build a timeline. We're going to use satellite images to build a timeline each year and how the Magruby station has changed. Three, apply atmospheric correction techniques. One specific algorithm that I'm going to apply is the CFMAS algorithm to solve problems like clouds in the image on the top and their shadow and the surface. So it's a big problem in the satellite images. For obtain results for long-term reforestation objectives. The final objective of this research is to provide data, provide maps from a group that organizations can use for create reforestation objectives. So, well, but how we're going to do this? Here's the method. First, we're going to use free open access satellites. They are the typical satellites that many researchers use. They are Landsat and Landsat 8. They both have the 6 same bands. As you can see, blue, green, red, near infrared, short wave infrared 1, and short wave infrared 2. The typical computer vision models use blue, green, and red, but for the purpose of the research, we're going to use the last 3 bands of the infrared. Well, let's explain about Use-CoordNet. Use-CoordNet is based on UNet. As you can see, here's the architecture of UNet. It is composed of 3 by 3 convolution layers. They are different stages. In every stage, the model identifies specific characteristics, features, and in each stage, after that, a concatenation is executed, and all the characteristics and features obtained are concatenated, and we receive an output segmentation map. So this is called in Use-CoordNet architecture a residual U-block. As you can see, here are the residual U-block of this architecture. Come here. As you can see, there are many residual U-block, and they are like a U, and what that is that the name of UNet. Use-CoordNet use the the same principles of concatenation in every stage, so it is a better architecture for these purposes. So here I extracted some data from Sentinel-2. These are images in different channels. The first thing that we're going to do is apply atmospheric correction. After that, calculate spectral indexes. The spectral indexes that we're going to use, they are NDVI, NDVI, NDMI, MMDWI. As you can see, here is the formula of these indexes uses use the previous mentioned channels, and our model is going to accept as inputs the 10 channels. This is a very challenging operation to do, and modification of the original architecture. And as you can see, the output is the segmentation map of my group. So in order to evaluate the accuracy of the model, we're going to use the typical metrics that are used in segmentation models. They are over accuracy, precision, F1 score, and recall. So before to end the explanation, I want to mention some challenges as a conclusion. First, the quality and availability of data is a challenge because Lancet 7 and Lancet 8 have a special resolution of 30 meters per pixel, and it is a low quality. And well, there are other satellites like WorldView 3 and 4, QuickView that can help, but they are not open access. But well, if research purpose is sent, can access them. But unfortunately, I was research about this, and I found that Ecuador isn't applicable for retain this data. So, well, the second challenge is the high competition cost. We use many convolutional layers, uh, images that have a high resolution scale. So this is the four main challenges that I am facing, like the researcher. So I think we are 80 minutes, so almost.
Pamela, have you finished it?
Yes.
Okay, that's great then. Thank you for your presentation. So we can now move on to the evaluation committee. Matthias, how about we start with you this time?
Yes, perfect. So thank you for the presentation. So I think just like the previous presentation, you don't have results because this is kind of a research proposal. So one question I wanted to ask is what problems do you think you will have by using UNet in this kind of data? Like what problems do you foresee that you will have?
Well, one main problem of UNet is that, well, in fact, we are going to modify the original or UNet used for net architecture. So the problem that I can see is that in order to modify the inputs, the input channels, is going to be a a difficult thing. Well, I was running experiments with this to modify with some data. Well, I think that's a big problem that can be upward.
Okay. So another question I had, well, another question more like a comment, is that the metrics you plan to use are classification metrics, but they're not specifically segmentation metrics. So you should take a look and use some segmentation metrics. So do you know some segmentation metrics that you can use?
Well, yes, there are classification metrics. Yeah, we have the idea is to have an original data set and compare how the model results, the model results with the original data. Well, these metrics are previous segmentation, mangrove segmentation research have applied these metrics. Well, I found useful for the purpose of the research.
Okay, yeah. So I suggest two metrics. One is the DICE score, and the other is the mean IUU, or just the IUU, the intersection over union. So these are standardized segmentation metrics. And that's important because if you write a paper about this, the reviewers will ask the same thing. Like, why do you use these metrics instead of like standard segmentation metrics? So you should make sure that the metrics are always selected according to the problem or the task. And maybe one final suggestion is to also look into uncertainty estimation, because you said that due to the quality of the data, sometimes it will be difficult to predict, in some cases, the mangrove segmentation. And in that case, you want to have like a probability for each pixel that this segmentation is correct or not, because then you can also use this, like the person that will actually look at segmentation to make decisions should also get confidences. So you can ask me later by email about this as well. Like I'm open for collaborations. And also I have collaborators from the University of Göttingen in Germany that they work exactly on these kind of problems. So we had a course before called Deep Learning for Forestry, where we had students doing segmentation of trees and stuff like that in satellite images. So we were also using the Sentinel-2 dataset. So you're interested, we can also set up collaborations about that for later.
Yeah, okay. Yes, I'm interested. Yeah, Sentinel-2 it's a good satellite too. It provides like a better resolution.
Perfect. Thank you.
Thank you, Matthias. Juan, let's go with you. You have the word now.
Yes, thank you for your presentation. Just to give me a little bit more context, can you repeat me if there is ground truth for the mangrove segmentation on this dataset that you want to use?
No. Well, the objective is to build a dataset, obviously with the ground truth, but yes, the idea is to apply the ground truth in this dataset. Now we'll have actually so in order to build a data set, we have to extract many images from the satellites, and well, in that case, I will perform this job.
How do you plan on getting the ground truth, or are you going to have some experts manually segmenting the mangrove, or what is the plan?
Yes, I was thinking on collaborate with other professionals of ambiental, well, other professionals of green health in my university, my faculty, and with them we can explore this area, and in specific the extension of mangrove in my province. Well, explore the area and apply the truth table.
Okay, because if generating the ground truth is another challenge, maybe that could be another, let's say, another paper or another work by itself. Because, for example, you could make some model in which you provide like a patch of mangrove, and then this model is expected to segment all the mangrove in a target image, just given that patch, for example. And maybe you can achieve that in a self-supervised manner, in which you compare the deep features of the patch against the deep features of all the patches in the target image that you want to segment. So even if like getting the labels seems to be something like an additional part to deep learning, that can also be deep learning itself if you incorporate self-supervised techniques for that. And that is also valuable, as you said. There is no ground truth for this kind of problems, or you have to make it yourself manually. But if you want to have like a very robust model, you need thousands of samples. And I know these satellite images, they are very, very large resolutions, which make it even harder for the annotators to make a very good ground truth, because you really have to zoom in and be like a very precise on how you annotate. So maybe another research direction would be how to automatically generate these ground truth segmentations.
Oh, okay, yes. Well, well, I forgot to mention that in previous research, some image was improved with generative models. For example, low resolution image was introduced, and they have a high resolution image. So that would be an option.
Yeah, there are many ways to handle these kind of problems, but just for you to have like a more like broad view of your very new problem that you have to handle end to end. Like there are many sub problems that it's not only the model that does the prediction, but also it could be another model that generates the pseudo ground truths for the next model and so on. But yeah, it's a very interesting presentation. Thank you.
Thank you.
Thanks, Juan. I think we can now go with Niels. Niels, you have the word.
Thank you, Will. Also, thank you, Manuel, for the nice presentation, the nice poster also. Also, I have the same concerns as Juan about the data set, so he already explored that part. One question for me is that you have a metric spectral indexes, but it's not clear for me how are you going to use that, or how do they help to evaluate the system in some way? Please, can you explain a little bit?
Okay, yes, the spectral indexes, in this case, for example, in DBI, is used to evaluate some specific characteristics on the surface of the image. For example, in DBI, chases the characteristics of vegetation, vegetation that can be used in order to segmentate specific locations of group in the surface.
So how are we going to use these metrics for evaluation or for feature extraction, or how are we going to use those?
We're going to use the metrics to train the model. We're to train the model, the model learn from the metrics because let me a bit few moments. Sorry, some noise around me. So yes, the indexes were they are going to be used on the model in order to train. For example, we have challenges like blue, green, red. The spectral indexes were calculated, and it would be like another channel with specific details on every pixel.
So basically, you are creating like a new matrix that is the computation of that matrix. Okay, got it.
Yes, that's correct.
Yeah, and if I understand correctly, you have different frames or different ways to create these input matrices, yeah? But for now, you don't know maybe which configuration or which combination will give the best option, yes? So do you plan to evaluate that part also as part of your experiments, or what are your thoughts?
Yes, for example, NDVWI, it is used for identify water bodies. For example, if this index is not used for the model, we can avoid it. I consider important because I have based on other research that it uses these indexes as common for these purposes.
Great, thank you very much. I think that's my questions. Thank you, Will. Thank you, Manuel.
Thank you,
That's great. Thank you, Niels. Thank you, Manuel, for your presentation. The next presentation would be given by Alejandra Pacedo. Yes?
Sorry, can I share my email on chat? Maybe someone can.
Yes, of course.
Yeah.
Can put it here in the chat.
Yeah, thank you.
No problem. So the next presentation would be given by Alejandra Parcedo from University of Central Florida. The submission title is called Multimodal Power Outage Prediction for Rapid Disaster Response and Resource Allocation. But this author has contacted us and he said that he's not going to be able to attend. He also did not he recorded a video of the presentation. So in this case, we don't have anything to fill in for his slot here. So I think that with that, we are finishing today's program, today's presentations. And then I would like to invite Matthias, Niels, and also Juan to go to another room that I created so that we can start with the deliberation. And then we return here to give our thoughts and the closing remarks, okay? And then, of course, after the deliberation, each of you will also have the opportunity to give your ideas and say what you what were your thoughts regarding to this seminar. Okay, we ask the authors and presenters that please stay here in this Zoom meeting. We will return maybe in 10 to 15 minutes. Okay, Matthias, Nils, and Juan, I've sent you another link on Slack so that we can do the deliberation. Okay, so thanks everyone. We see you again in 10 to 15 minutes.
Someone needs to mute Zoom, maybe.
Is it better now? Is it better now?
No.
I don't know what happened.
So maybe you have your Zoom still open. I had to
Hello, everyone. We are returning now. Yes, just waiting for Matthias. It's where Matthias is. So, hello again, presenters, authors. After careful consideration from the evaluation committee, they have reached a decision. But before we move to decision, let's see if they have anything else they would like to give some considerations. Okay, so you can use this time to just say what were your thoughts for this UC track and maybe give some other comments to the authors, okay? Yes, you can go ahead. You can start with your considerations.
The first thing is I would like to congratulate all students that participate in the undergrad consortium. It is the first year that we are doing this undergrad consortium. The main goal is to promote them, that you find a path in research, that you discover you like this venue, and so on. And also, if you are here, you already pass a qualified committee that evaluates all your proposals. So you have potential to do a master, to do a PhD abroad. So that's our main goal, try to motivate you that you have the potential to go outside. There are some opportunities in Brazil, in US, in Europe. So feel free to look for those ones. And all of you are winners if you are here, okay? Thank you very much.
That's great. Thank you, Niels. So let's move on to Matthias. Matthias, you have the word now.
Yes, thank you. So I also like a lot all the presentations, and also I would like to congratulate the organization. I think organizing an undergraduate consortium is a great idea, because I also think about when I was an undergraduate student, like maybe 20 years ago, we didn't have these kind of opportunities. So now that you have these opportunities, try to make the best out of it. So after this, if you have questions, just reach out to the community. If you want more feedback, and also try to share it to your own communities. So maybe, because now you will probably graduate, let's say within 1 year, and then as Niels says, you will do a master or a PhD or other kind of positions, but also try to share this with your local communities. So maybe people that are now, let's say, first or second year undergrads can also take care of this opportunity in the future. But yeah, but as Niels says, you are all like in the top of the field in your organizations right now. Thank you.
That's great, Matthias. Thank you. So Juan, you have the word now.
Yes, I would like to repeat that I think you are already ahead from your peers, so you should feel very good about that. And I also heard that many of you had problems with computation power, so maybe that's something we can look out during the workshop at CVPR. And I'm pretty sure that there should be a way to provide compute power for undergrads, and even more for those who get the first places in this kind of consortiums.
That's great, Juan. Thanks a lot for your comments. So we can now move on to present the awards. I can say with a lot of certainty that it was not an easy task for the evaluation committee, right, everyone? We discussed it a bit. We've had a lot of very, very nice results, very, very nice participation. So it's with great honor that we share these remarks with you, because just making echo to what Juan, Nils, and Matthias said, we are feeling very happy on the level of the students that are here today. These are not easy tasks. These are not things that are usually taught in the graduate courses, right? So you just usually have one course for computer vision. So most of them is actually your own work to go after these results. So congratulations again. So you're now seeing my screen. We will go after the best presentation, the runner-up, and also the honorable mention. For the honorable mention, we have Isabela Ribeiro from Voxelabs at the Federal University of Pernambuco with the work Evaluating Structural Distortion in Anonymized Faces. Congratulations, Isabela.
Congratulations.
Yay.
Thank you very much.
Parabéns.
I'm really happy to be here. Thank you.
Great, great. Moving forward to the
We
runner-up.
should include some suspense. It's okay.
Yeah, I think the
It's
suspense
okay,
is
go
now
ahead.
broken. So moving forward to the runner-up, we have Jose Barba from the Trujillo National University with the work Segmentation of Oil Spill in the Peruvian Sea for Rapid Location and Cleaning using Computer Vision. Congratulations, Jose.
Congratulations, Jose.
Thank you very
Congratulations.
much. Thank you.
News,
Felicidades.
how do you want to do the suspense for the first place?
I don't know.
Okay.
Have some drums
So,
to take some sounds.
so moving forward to the best presentation of today, we have Manuel Malha from the Machala Technical University with the work Mangrove Net, Mapping and Monitoring Mangrove Ecosystems based on new TuNet model using satellite images. Congratulations, Manuel.
Congratulations, Manuel.
Congratulations.
Yeah, I will say that overall, all works that were accepted into the second step were considered as candidates for these prizes here, these awards here. Again, the board had to deliberate a lot in order to reach these conclusions. But again, making echo of what they said, all of you are absolute winners and all of you are absolute ahead of your peers because working with this topic is already complicated as is. But for us that are based in Latin America, that has a lot of limited resources, as we know that our universities have, it's amazing to see the level of the work and quality that we're seeing in this consortium. So congratulations to all of you that were also present here today.
Yeah. Thank you, Willie. Can I add some thoughts before?
Of course, yes. Of course, feel free.
The first thing is like we are going to give some certificates for these winners. Probably we will send by email. There will be some monetary prizes for the first and the second place. We haven't decided yet exactly the quantities, so we will send. Don't expect too much. It's only like some small amount that at least it will help you to buy some books or decide how you can help for your site. And also, I would like to ensure that this is the first time that we have this opportunity. Please take the best of it. I don't know. I know many of you cannot go to CBPR this time for the visa issues. Hopefully we can fix next year, but feel free to attend online our workshop. Feel free to send email to Will, to me, to Juan, to Matthias. And also if you have any questions or you need any help from our side, please let us know so we can help also in the best way that we can. Thank you very much. And thanks also for your time here.
Thanks, Nils, for your words. I think that with this, unless Juan, Matias, or any other presenter wants to add some more info, I think that we can end today's consortium.
I can say one short
Yes,
thing.
Matias.
That
Yeah, sure.
these awards are important because you should definitely include them in your CV, and this make a difference. Let's say when you apply for an internship or something like that. So
Exactly.
because it's like a small stamp of quality, let's say. So make
Exactly.
sure to include them in your CV and in your LinkedIn, for example, or something like that.
Yes, I was about to say the same. Make sure to flex your participation in this workshop. Like even your participation is already a very good contribution to your CV, and it will make a difference.
Yes, exactly. If you were able to be here and present, this means that you already went through the peer review process, your paper was accepted, so that's already something that should be included into your CV. And you might remember that when you submitted the work, there was an option saying if we can share this into the LatinX in AI forums. So the recordings and the posters will be made public, and all of you will have a shareable link that can be added to your CV, that can be sent together with a cover letter, for example, so that other people can know the contributions that you've made since you were undergrads. Here in the chat, Nils and Matthias has already shared the emails, so feel free to ping them, ask them for collaborations. I think that that's the main goal of this type of session, right? And I would, again, like to congratulate all of you for the amazing work that we have here today. Okay, that's great.
Thank you.
With that, we are closing now the 2024 Undergraduate Consortium for the LatinX in CV workshop. We hope to see all of you again next year.
Thank you, and see you on the workshop, maybe online. Thanks.
See you.
Yes, thank
Bye-bye.
you.
Thank
Thank
you.
you. Bye-bye.
For this
Bye.
opportunity. Thank you.
Congratulations and thank you.
Thank you.
Congratulations.
Thank
Thank
you.
you.
Bye.
Bye bye.
Bye.
Bye.